You guys have the 7-8, using exponential and logarithmic functions. The two equations you need to know are up there. One in red, one in blue. Okay, and these are in function form. You can make them equation form sometimes, exchanging f of x for y. You know, interchangeable parts. Okay, so it might say f of x equals, might say y equals, depends on the problem. Alrighty, but both times very similar, right? A times e to the k times t power, a times e to the negative k times t power. Okay, very, very similar. A is your initial value. This stuff's important. A is your initial value. T is time in years. And K is a constant that represents the rate of continuous growth or decay. All right. So obviously, if it's an exponential growth problem, you're getting bigger, K is going to be positive. If you're getting smaller, decreasing, K is going to be negative. Okay. The K is whatever rate your stuff, whatever it may be, is either getting bigger or decomposing or getting smaller. Okay? We will for sure get through the K problems today. I don't know if we'll get to all the growth. Okay? That's where I'm kind of losing track of. All right? Everybody good? Once you move to exponential, and we're going to start with decay, like I said. Once you move into decay problems, okay, and the more complicated ones are ones like this. You're talking about different substances, okay? And one of the most common substances they talk about is carbon-14. Okay, however much carbon is left in bodies and yada, yada, yada. I don't know all the technical stuff because I just teach math. Okay? I don't know what carbon-14 really is. I just know how to work with it. Okay? The nice part is what we're going to do now is we're going to determine that value for K that carbon disintegrates at. Okay? Once we do this, you will never have to do it for carbon-14 ever again. I will give it to you. Make sense? Okay, this is going to be part of your problem. All right? You're going to have to do it one time in your homework for, I believe, potassium 12, potassium 11, something like that. Potassium 40, I was close. So close. Okay? So you'll have to do this one time for potassium, but after you get K for potassium 40, every potassium 40 problem you do, you'll have it 4. Make sense? Okay, because if you look ahead, we're going to have about 4 other carbon-14 problems that you'll never have to find what K is because we're going to do it right now. Okay, kind of makes sense on where we're heading? All right, let's do it. Half-life of a radioactive substance is the time it takes for half of the atoms of the substance to disintegrate. The half-life of carbon-14 is 5,730 years. Determine the value of K for carbon-14. Whoop, wrong button. And there we go. All right, since you are doing decay, you want, obviously, the function. Okay, so I do y equals a lot of the times. You want y equals A times E to the negative K T. Okay, we're going to use that formula. Okay, let's go through, let's label some stuff that we do know. We know what?
Initial value.
Do we?
No, you know the half of the initial value.
Just okay, well, hang tight. Let's go with really obvious first. The really obvious one we know is the years. We know the time. Okay? We know the time is right here, 5,730. We know that. Okay? Now, one of the most complicated things with this lesson is this concept. And once you get past this concept, this lesson kind of goes. It kind of flows. Okay? Let's say that all the carbon-14 is right here. All right? There's my carbon-14. How much is that? If all of my carbon-14 is in that cup, right there, how much is that? All of it. It's all of it. Okay? It's all of it. Now, I'm not going to open it up because it's radioactive and look how much is actually there until tomorrow morning when I drink it. Okay?
Radioactive.
Yeah. Now you know why I am the way I am. Makes sense now, right? He's drinking radioactive coffee. Oh, that makes sense. You can go home to your parents. I learned a lot about my teacher today. You know it's all there, right? Okay? So we know our initial value of A is all of it. Express it as a percent. 100%. Now, I'll tell you that as a number. 1. Okay? You know you have 1 A. Okay? We know the left side is e to the negative k.
What is
I thought one was it.
why isn't
1% of A. 100% of A. 100% of A. Okay?
what's A?
The initial value.
Because we don't know exactly how much it is. Okay? We can't say for sure it's like 500 grams. Okay? That's what that would be. Okay? Saying it's 500 grams. We don't know how much is actually there, but we know that we have 100% of it. Because what operation is between here? Multiplication of A.
So is that one necessary to put?
You'll see why I put it in a second. Okay? Technically, no. All right? So e to the negative k, and we know that t is 5,730.
Don't you have to find out the whole value
Of,
the half-life itself?
well, maybe in a separate problem, yeah. But right now, you're just trying to figure out the k for carbon-14.
Okay.
Okay? That's probably like a new problem. All right? We start with 100% of A, whatever it is. How much are we going to end up with? Half of it. Half of it, right? Okay? And since you express 1 as a number, you can express that fraction, okay, 50%, as a number. You can do it 2 ways.
1/2.
1/2, which is my way, or 0.5. Okay? I like a half. Why? Because I like fractions. Okay? Everybody good so far?
Wait, no, why did you put 1/2 A on the other side?
Because you're still ending up with 1/2 of it.
Where's my library?
Okay? Now, since, and this is the only time I've ever said this is okay to do, you have A's on both sides of your equations, what can you do? You can cancel them out, okay? Which leaves you 1/2 equals, now the 1 times the e becomes just e, okay? Everybody good? E to the negative k times 5,730. Which now turns you into a problem from 7-7.
You move up, yeah.
Okay, so now you break out an ln. All right, take natural log of both sides.
Wouldn't that be?
Okay. What happens on the right-hand side with the natural log on this e?
Why we cancel
They cancel out, and this exponent comes
down?
down. Okay, so I'm going to do this actual multiplication now, and I'm going to go up here with my problem. Okay. So you should end up with ln natural log of 1/2 equals negative 5,730. Okay, and then you finish off by dividing by that negative 5,000. So natural log of 1/2 divided by negative 5,730 equals k. And then when you run that through your calculator, you should get k to be 0.00, I think 3, yeah, 0.0012.
Okay, carbon 14 equals that.
Carbon 14, the half-life, the half-life decaying constant for carbon 14 is and always will be 0.00012. Okay, so now that I know you know where that comes from, any problem on a test, on a quiz or a homework, if it's talking carbon 14, that's the K you use. If it's a problem on a test, I will give that to you.
The half-life of the decay.
Of the decay,
You're not
right?
going to even know how to do this.
Okay, so now, all right, so now we're going to move into actual problems, okay? A paleontologist examining the bones of a prehistoric animal estimates that they contain 2% as much carbon-14 as they would contain when the animal was alive. How long ago did the animal live? All right. So now you know other things. Okay. Since it's still decay, we are still using the y equals. We're still using the y equals a e to the negative kt power. Okay. What are we trying to find? Trying to find time. Okay, so we're going to look for this. What do we know?
2%.
Okay, we know the 2%. We'll come back to that in a second. We know k now. Okay? So now instead of going through that whole long process to figure out what k is again, you just use 0.00012 for k. Always for carbon 14, yeah. Okay? Makes sense now? You don't. I'll give it to you. Either I'll give it to you, Paul, or you'll have the opportunity to go look it up. Like if it's on a homework, then you can go look it up. Okay? All right. And then same like last time. We know that the animal started, right? Prehistoric animal, yes. We know it started with all of its carbon-14. We don't know how much it was. We found it with how much? 2%. Okay, so 0.02 A, because it's times whatever's left, whatever's there, equals A e to the negative 0.00012 times t power. Okay? Everybody good? Makes sense. All right. Divide out the a's. Okay, this will be the last time I write the a's in there to start with. Okay, but understand that they'll always cancel. Make sense? Okay, assuming that they're in both sides, that you're given like a percentage of what's left.
They need to put the natural log and then
Mm-hmm.
and then they cancel out the one log
I'm going to skip the natural log canceling the on the right side step. Everybody okay?
Yep.
All right, so I'm going to take natural log of both sides. Natural log of 0.02 equals, like I said, natural log cancels that out, so negative 0.00012t. Divide by that decimal. That was a big H, L, N. There we go, 0.02 divided by negative 0.00012 equals your time, which is approximately 32,600 years. Okay, so like I said, this is talking about the same problem, just a different slide, all right? If prior research points to the animal being around 20,000 years old, how much carbon-14 should be in the animal? Okay, so now we change what we're looking for. Okay, we know K, obviously. We know T. We're trying to find A. No, we know A. Okay, how much carbon-14 did the animal start with?
All of it.
All of it.
Except one.
So that's 1. So we're trying to find Y.
Okay.
We're trying to find how much is left after 20,000 years. Make sense? Okay. So Y equals A E to negative 0.00012 t power. Okay. Like we said, it's going to be right. Okay. We're trying to find y, whatever y, or f of x. Like I said, that could be f of x. I switch it to y. I just do. Okay. Trying to find it. We know the animal started with all the carbon-14 it had. We don't know how much that is, but we know it's all of it. So A is 1. Okay. 100% of it. So we don't need to write it. E to the negative 0.00012 power. That's because all of its times 1.
So it's the same as last time I was writing.
Exactly. Okay. Because you're going to solve for y, which is going to be in a percent.
You're not looking for it.
Right. You're looking for y.
But I thought the only way you can get rid of a number if you can get rid of it on the other
Hang-
side.
Hang tight. Hang tight. Hang tight. Okay. Hang tight. Okay. Times 20,000. All right. Do the exponent multiplication. You can either do that right away in your calculator or show that extra step. So e to the negative. It ends up being, I think, 2.4. Right? And then once you do e to the negative 2.4 power, and then you write that number as a percent, okay, because you're talking about the percentage of carbon that's left over, it should be about 9. Okay, so now we're going to change the question just a little bit, okay? A specimen that originally contained 42 milligrams of carbon-14 now contains 8 milligrams. How old is the fossil? Okay, so now what changes when we talk about my radioactive coffee is what?
We know it.
We know how much is in here, and we also know how much is left over,
But we know the half-life.
okay? Which you still use, okay? The decaying of the half-life you still use, which is that 0.00012 number.
No, we're just finding time.
Now you're finding time. Okay? So it'll be basically two types of problems. Either you will know how much is in here to start and how much you finish with, or you know the percentage of what was there and what is there now. Okay? That's why I said that y on the right side or the left side is kind of dual purpose. Okay? Make sense? Yeah. Plug this one in and try it. Alright? See how you do. So hopefully, okay, two things. Number one, divide by 42 on both sides first to isolate that e. Okay, because you got to isolate that e from last section. Remember 7, 7 to take the natural log so it cancels out. Everybody good? Make sure when you get down to the bottom and you're doing this in your calculator, if you do it like fractions, and by all means, if you want to make these decimals, you can. It's because they'll typically be somewhat reasonable decimals. I always keep them in fractions because 4/21 is a lot easier to write. But either way, make sure you have this formatted right when you go into your calculator. Okay? And always make sure, I don't know if I said this yet this semester or not for this chapter, make sure you show me this. Okay? Because if you show me this and your answer is wrong, I assume you typed something in wrong and I'm only going to take off like 1 point. You show me this and then you go straight to that and it's wrong, oh boy, I'm going to be mean to you. Show me your algebra, show me you know what you're solving for. Okay, makes sense? Okay? Yeah. Yeah. Okay, so now we're going to change it up to go to growth. All right? In 2007, the population of the state of Georgia was 9.36 million people. In 2000, it was 8.18 million people. Number one, determine the value of K representing Georgia's relative rate of growth. Number two, when will Georgia's population reach 12 million people? This is a very good type of question, okay? You will see this. This is basically how most of them will be presented to you. Okay? You will be given a situation where you have to find K, and then you turn around and use that K to answer a new question. Okay? Make sense? All right. This time we're doing growth. What changes what equation we're using?
Just the same equation. But
Same equation? K is
positive.
positive. So y equals A times E. Now to the positive KT power. Okay? They won't always say growth, but you should be able to read the problem and realize either stuff's increasing or stuff's decreasing. Make sense? And then I'm assuming you can use your logic and, oh, that means growth. Okay? Alright, so determine the value of K representing Georgia's relative rate of growth. Alrighty. What do we know?
We know it's exponential population and it's old population.
Okay, we know it's new population, we know it's old population. Okay, place one with what? Place them. Which goes where?
Y is 8.18.
Thinking the opposite? I was thinking the opposite too. Okay, because remember, the left-hand side, that Y is your new. A is your initial. So basically you ask yourself, what came first, 2000 or 2007?
I flip.
You did flip, yeah. 2000 came first, so the 2000 population is your initial, which is the 8.18. Okay, and the parameters that they give you, the 9.36 is your new. Okay, so to start, number one, you got 9.36 equals 8.18 as your initial times E. How many years?
7.
Oh, very good. Good job, kiddos. 7 years. Because it grew in 7 years. Okay, makes sense? And we're trying to find K.
Remember, I feel like that was sarcasm, but you didn't hold up your side.
So do you divide out the 8.1?
Now, yep, that's exactly right. Because everything always, this always goes back to sevens
Do we round it
questions.
to 1,000th or 100th?
Let me talk about this. Okay, I'll get there. All right. You always go back with these to 7/7 questions where you got to get E by itself so you can take a natural log. Okay, and since E is always going to be here, you always take a natural log. All right, make sense? Now, your question, Mr. Kristoff, when you divide both sides by the 8.18, what do?
1.1442542.7.
Yeah, it's huge, ain't it? It's 936 divided by 8. It is 1.144254279. Ew. Here's what I write. 9.36 divided by 8.18. Yep. And I leave that as a quantity. And then I let my calculator do that work for me. Okay. I'd rather write 6 numbers than, 12. Times E to the 7K. Okay. If you do it this way, you're going to save yourself rounding errors. All right? Because if you round here and then you round again at the end, you're going to be off. You're not going to be off by a lot, but you're going to be off enough that I don't like it. Okay? You're going to be off far enough that it's going to be different from my answer, different enough. And you may have done everything right, you just rounded right there. Okay? So leave that as your quantity and let your calculator do the work for you and round at the very end. Okay? Kind of like your interest problems. Okay? Make sense? Natural log to both sides. So natural log of 9.36 over 8.18 equals 7K. Alright, going over here. Natural log of 9.36 divided by
the natural log just flips like the E flips the
8.1.
natural log.
1/8 all over 7 equals K.
But my question is, do you put? Let me round that to the nearest.
Sorry. So round this. They round this one to the nearest. Let's see, 10th, 100th, 1000th, 10,000th, 100,000th. Why, I don't know. I'm going to do it for this problem. Okay, just so we're on this page with the book. So K equals 0.01925. All right, and that's K that we're going to use for number 2.
Wait, what is K? What?
K is that constant of growth.
So is it that many billion people or million people?
What do you mean?
Never mind.
Okay.
I feel like it was
No, it's increasing by.
It's increasing by that many people per time frame, per year, per whatever.
Is it a percentage
don't
or
really
just
need
that
that.
number?
Percentage basically, so like 1% per year or something like that. Okay.
Wait, that's talking about million. So that.
So then, okay, right,
Million people?
probably.
So then, like on a test, we leave it like that.
Right, because that's the answer to 1. Because all you want to do for 1 is find that K. And you would leave this because we're going to turn around with number 2 and then answer 2's question where we use this K. So this constant here, this decimal, you want to keep decimal. Okay, make sense? Okay. Watch my trick. This is a cool party trick if you ever need one. Ready? And voila. Oh. Number 2. Tough crowd today. Number 2, determine Georgia, or when will Georgia's population reach 12 million people? What are we looking for now? We are looking for time, okay? And we know what? We want our final amount to be what? 12 million, right? So we know 12 equals. Okay, now, let's talk about this. What goes next?
9.36. Just kidding, no. 8.18.
9.36. Just kidding, no. 8.18. I got a question for you. Technically, it doesn't really matter.
No.
Technically, it shouldn't.
Because it's the rate.
Because either one, you can consider either one as your parameter for your starting point. Because you know both. Okay, you're given both, right? I tell you that. I wouldn't lie to you. Make sense?
Mhm.
Okay? Remember that. I wouldn't lie to you. You can technically use either one, okay? Now, keep that in mind, okay? So I'm going to use 8.18. Is anybody going with 9.36 if they already started? Okay, Anson? You doing it? Do it, okay? You kind of zone out, all right? You do your thing. I'll do mine, okay? And we'll meet in the... You do your thing, I'll do mine, and we'll meet in the middle. You two, go, okay? So I'm going to do 8.18, saved it, times E. We found out the K on the other side was 0.01925, and we want to find T. Okay, so like I showed you on the last one, I'm going to divide that 8.18, but not really. I'm just going to write it as that quantity. Equals. I'm going to cut out the... Or no, I'm not. I'm going to write it out. E.01925 T. Take my natural log of both sides. 0.01925 equals T. Alright, going over here, kind of working backwards with this one. So natural log of 12 divided by the 8.18 all over the 0.01925 equals T, which should be
1.99.
approximately 19.9. Okay. So that's what I want. That's what I want right there. Okay. We all got 19.9. Okay. Anson, what'd you get?
I got 12.9.
12.9. All right. Now, why did he get 12.9 and we got 19?
You started a different year.
Started different year. Okay. So to their point, because you guys had me befuddled, because I'm like, oh, they already thought about that. This is awesome. I love you guys. 19.9, not creepy way. 19.9 is not your answer. What is the answer?
2019.
Up.
2020.
2020. Round it up. Okay, that 0.9, round that up to 20, make it 2020. All right? You guys, if you did from 2007, you would round it up to 13, add it to the 2007, make it 2020. All right? So no matter what, that's about 19.9 years. So when will Georgia reach that milestone? 2020.